What's up, guys? I'm Pierce from Snappy Data, and I'm here to show you a demo we recently created. This demo runs in Zeppelin, which is an interactive data analytics viewer, very similar to an IPython notebook. And it's deeply integrated with Spark, which is a distributed data processing framework. Our product, Snappy Data, is also very integrated with Spark. We like to call it a distributed in-memory synopsis store. And if that sounds a little mysterious, hopefully we'll clear it up by the end of this. So our demo's across a set of airline data from 2009 to 2015, about 40 million records in total. And what we're going to do in this demo is show you some simple analytics queries over the set of exact data, so all 40 million records. And then we're going to show you the same queries over a set of the sampled data, which is something that our product does. So to start, the first thing we do is create this case class that we're going to use to parse the data, and write this little method to parse all that data into the case class. Pretty standard Spark stuff. And we extend the Spark context here with what we call the snappy context. But as you can see, it's pretty straightforward. And go ahead and grab the data and parse it here. And then we take the data and put it into a data frame. This is the Spark data frame. So having it in a data frame, you get all the benefits of the Spark data frame. And then what we do is take that data frame and use a method called stratified sample to take stratified samples across these three columns of the data: unique carrier, year, and month. And what we want to keep is about 3% total of the original exact data set. And we, of course, take that and put it into memory. So first, we went and wrote some Spark SQL here to see how many rows total are in the exact data set. So as you can see, about 40 million. And then we did the same thing to see how many rows are in the sample data set, about 1.5 million, so a much smaller memory footprint. And then, of course, here we have the estimation from the sample data set on how many total rows there are. And as you can see, it's only about one row off. And so the first analytics query we did is which airline has the most flights each year. So we can go ahead and run that. And this one is running over the entire exact data set, so all 40 million records. And down here, what you'll see is abbreviations of each airline. So we have Delta and Southwest. And you can see running that took about 11 seconds, and this is the result here. And then we did the same query over the sampled data set. So we'll go ahead and run that. As you can see, it took about 1 second. And if you look at the pie charts, they're almost identical. And one thing to note, of course, is that having this run in Zeppelin, it introduces a tiny bit of overhead. So both queries actually run faster. The next query we did was which airlines arrive on schedule. So we'll go ahead and run that. And of course, that's also running across the all 40 million records here. And on the bottom, you have the airline abbreviations and, of course, the delay. So that also took about 11 seconds. As you can see here, Alaska seems to have the best, least amount of delay, and some of these other ones. And then we're going to run the same query across the sample data set. And you can see it took about 2 seconds, so quite a bit faster. The next query is there a trend in arrival delay over the years? So this is across all airlines. Is there some kind of trend happening in arrival delay? So over the exact data set again on the left here, and again about 11 seconds. You see the graph here, and it shows, looks like in 2012 the arrival delay dipped down, which is nice. Same query over the sample data, and takes about 2 seconds. And of course, looking at the two graphs, they look just about identical. Now with this query, we added the error estimate in. So if we click here and look at the actual results, we can see we have an error estimate of the sample. So what this means is that for this value that it came back with, it's plus or minus 0.29 percent confidence, or actually this is an 80% confidence. So we're 80% confident that this number is within 0.29 of the actual number, and that's, you can see the error estimate for each number here. So kind of a cool way to see how close, or to get a sense of your confidence in the answer. And so in the next example here, we have a user-defined function that we created, and what we're going to use it to determine what's the best time of data travel. So we're going to run that over the exact data. Again, this is going over all 40 million records. And once again, takes about 11 seconds. Going to use the same query here on the sample data, and it's about 2 seconds again. So and if you look at the two graphs, they're pretty much identical. And as you can see, this kind of goes on and kind of follows the same pattern. But the point is that using Snappy Data's synopses, you can get answers to analytics class queries much faster that are very similar to queries over the exact data set. And to learn more about this, you should check out our site, www.snappydata.io. And then we also have a blog there that goes into a little more technical detail about how our product works and what synopses tables are. So thank you for listening, and I hope you enjoyed it.